Hello, Mr. Kissinger here at the Citizenship Academy in Syracuse, New York. Today we are doing Grade 5, Module 2, Lesson 25. We're using basic facts to approximate decimal quotients with two-digit divisors, reasoning about the placement of the decimal point. So we're going to be estimating this time and using division with decimals. So if we look at letter A here, it says estimate the quotients. We have 3 and 24 hundredths divided by 82. We're gonna be when we're estimating, we know that we might get different answers depending on the way that we estimate. So there's not going to be like an exact right answer. We just want to make sure that our answers are reasonable. So we want to get kind of in the same ballpark, no matter how we estimate these, as long as we're doing it in a way that makes sense. So if we look at 3 and 24 hundredths and we look at 82, well, I want to find two numbers that kind of work well together. And so I might round 3 and 24 hundredths to 3 and 2 tenths, or 3 and 20 hundredths, however you want to look at it. And then I'm going to divide by 80 because I know 8 goes into 32 4 times, so that 32 is a factor of 8. So it's going to be really easy for me to work with. And I'm going to split this into two different problems. I'm going to do 3.2 divided by 8 and then divided by 10. Because dividing by 80 is the same as dividing by 8 and then dividing by 10. 3 and 2 tenths, or 32 tenths, divided by 8. Well, we know that 32 divided by 8 is 4. So we're going to do 32 tenths divided by 8 is 4 tenths, which is 0.4. And then I need to divide that 0.4 by 10. So 4 tenths divided by 10. And again, we're just going to move our decimal point over once to the left. We're really moving all of our place values one spot to the right, but we're going to end up with 4 hundredths. Just about. These squiggly equal signs mean approximately or about. So it's going to be about 4 hundredths. All right, so let's look at the next one. 361 and 2 tenths divided by 61. Well, instantly what jumps out to me is I see a 36 and I see a 6. And I know that 6 times 6 is 36. So let's make this 360 divided by 60. And then I'm going to do 360 divided by 6 divided by 10. And because of the community property, I can switch these. And I'm going to do divided by 10 and then divided by 6. And I should say the associated property. The associated property will let me divide, change my parentheses around. And so I'm going to do 360 divided by 10 gives me 36. 36 divided by 6 is 6. So 361.2 divided by 61 is about 6. Next we have 7 and 15 hundredths divided by 31. So I see a 7 there. Well, I know that 7 times 5 is 35. So I could use that. Maybe I'll do 7. Yeah, let's do 7. And we'll do 7 divided by divided by 35. So, I don't want to do a 5. I don't want to do a 5 at the end, because then if I do a multiple of 10, I can think that it can be easier. So let's look at it differently. Let's change this to 30, because 31 is really close to 30. And what do I have that's a factor of 30, or a multiple of 30, that would be easy to divide? That's near 7 and 15 hundredths. Well, if I did 30, I can go to 6. That's not super close to 7 there. If I did 70, 75, 7.5. Let's do that. So if I have 7 and 5/10 divided by 30, well, I can do 7 and 5/10 divided by 3. And I can also look at 75/10. 75 divided by 3 is 25. So 75 tenths divided by 3 is 25 tenths. So 25 tenths is 2 and 5/10. And then I'm going to divide 2 and 5/10 by 10. And I'm going to get 25 hundredths. All right. So let's move on, and we'll do a word problem here with some estimating. We'll just do this number 3, letters A and B. Edward bikes the same route to and from school each day. After 28 days of school, he bikes a total distance of 389.2 miles. Estimate how many miles he bikes in one day. So if he rides the same route to and from school after 28 school days, he bikes a total distance of 389.2 miles. So if he does a total distance of 389.2 miles, if we want to find out how many miles he rides in one day, we need to divide the number of total miles by the number of school days. So we have 389.2 divided by 28. Now we need to find two numbers that are close enough to those numbers that we can round to. And what I'm seeing is 389. How about 390 is really close to that? And we could divide by 30. Because 300, 30 goes into 300, and I know 30 also goes into 90. Because 30 times 3 is 90. We have 30, 60, 90. So I'll split that into two different problems here. So we'll do 390 divided by 10. And that would be 39, and then 39 divided by 3. If we weren't sure, we could do it the long way. Do 39 divided by 3. It was in 1 time. Subtract our 3. Bring down our 9. And we get 13. So Edward bikes about 13 miles. Bikes about 13 miles. If Edward continues his routine of biking to school, about how many days altogether will it take him to reach a distance of 500 miles? So now that we know that he bikes about 13 miles per day, how many days would it take him to get to 500 miles? Well, we have 500 divided by 13. And we can figure out about how many days. And we don't have to do 500 divided by 13 necessarily. We can estimate, and we can make these numbers. How about, well, 500 is pretty close to 520. And we could keep 13 the same. Because I know 13 goes into 52. Now, you wouldn't have to use the same numbers if you don't know that 13 goes into 52. But that's easy for me to remember just because I know there's 52 cards in a deck and there's 13 cards in each suit. So I know that 13 goes into 52 4 times. But you could also do 450 and 15. You could do I was looking at maybe doing 480 and 12. So there's a number of different ways you could do it. I'm going to do it this way, and I'm going to do 520 divided by 13. I know that 52 goes into 13 4 times, or 13 goes into 52 4 times. It goes into 520 10 more times. So would have 40. But let's do it a different way. Let's do it a way where I can have a multiple of 10 here. What if I just did 500 and I kept that the same? And instead of 13, I did divided by 10. I would get 50. So, it could be 40 days, it could be 50 days. It just depends on what we use to estimate, but we're going to be in the ballpark or around the same, about the same amount of days either way. So the closer you can keep your numbers to each other, the more accurate your result is going to be. So that's all the time we have for today. Thank you guys for tuning in and look forward to seeing you next time.